Hello everyone. Today we will do geometry problem solving session. We will do problems involving elementary methods. So let's get started. So this is Elmo 2017 P2. Share whatever ideas you have and feel free to interrupt if you have any doubts. So is the problem clear?
Yeah.
Okay.
How much time do we have to think about it?
Yeah, you can take like some 2-3 minutes more, then I'll share whatever ideas you have. Yeah, and if you want a hint, I can give. That's fine for everyone. Okay, so any ideas?
Yeah, a hint would be nice, probably.
Okay. So directly thinking about orthocenter of APQ seems a bit hard. So try thinking about some other property of orthocenter. Some other nice property about orthocenters. For example, reflections of orthocenters are good. So think something related to that. Okay, so we know reflections of, so suppose you have a triangle, then we know reflections of orthocenter over its sides, over its side and over midpoint lies again on the circle. And we know if a reflection over midpoint is actually the antipode. So if we see triangle APQ, we already have A antipode. A antipode in APQ is H. So we basically want to show that HH dash has its midpoint as midpoint of PQ. So let's add the midpoint of PQ. Let's call it, say, N. Now we want to prove that H dash and H has its midpoint N. Okay, so in other words, if we take a homotheity about H with ratio half, it should bring H dash to N. And H dash is a point on the circumcircle. So what does a homotheity of ratio half about H bring the circumcircle to?
9 point circle.
Yeah, so you want if we prove N lies on the 9-point circle of ABC, we would be done. Can you see why?
Yeah.
Yeah, so try proving that N lies on the 9-point circle of ABC. And yeah, we have this thing that it passes through midpoint of BC given. So Let's add the 9-point circle. Okay, what other good point do you think is when it comes to 9-point circle and this circle with diameter AH?
The feet of altitudes.
Yeah, feet of altitudes.
And the midpoint of AH.
Yeah, if you add,
Yeah.
so you can call this HA, HB, HC, and let's call this, okay, what? R. So R is the midpoint of AH and R lies on the 9-point circle. And yeah, now we are close. Now R is center of AH. Okay, for N to lie on the 9-point circle, what angle condition should it satisfy? RM look good point.
Okay. So like N is midpoint of PQ and R is center of that circle. So and PQ is a chord. So angle RNP is 90, which means angle RNM is 90 and angle RHAM is also 90 because HA is feet of altitude.
Yeah.
So RNHAM is cyclic, which means N lies on NPC.
Yeah. Did everyone follow the proof? Should I go over it once again? Yeah. So we have R is the center of the circle with diameter EH and N is the midpoint of PQ. So RN will be perpendicular to PQ. And that would imply angle RNP is 90, and which would imply angle RNM is also 90 because NP M are collinear. But we also know angle RHAM is 90 degree. So this together imply that RNHAM is a cyclic quadrilateral. Is cyclic quadrilateral. So that implies that N lies on 9-point circle of ABC. And if you take a homothety of ratio 2, about H, it sends the 9-point circle to circumcircle ABC. So it will send N to a point on circle ABC. But if you see triangle APQ, H is the A antipode and N is the midpoint of PQ. So this reflection will be the orthocenter of APQ, which would lie on circumcircle ABC. So is the proof clear?
Yeah.
Okay, cool. So let's move on. Just a second. Yeah. This is Elmo 2018 P1. So you have triangle ABC with orthocenter H. And center O. P is the midpoint of AH. So Y is midpoint of PX. So we have to prove Y lies on 9-point circle. 9-point circle. So is the problem clear?
Yeah.
You just want the perpendicular at Y intersection BC to be midpoint.
Sorry, can you repeat once?
If M is midpoint of BC, then you want MY perpendicular.
Yeah.
So if O dash is reflection of O across BC, you want O dash P perpendicular.
O dash is reflection of O over PT.
No, O dash is reflection of O across BC, then we want O dash P perpendicular to the line.
Yeah.
Oh, but O dash P is parallel to the median because AP O dash M parallelogram.
Yeah. So AYM should be collinear.
Yeah.
Yeah, I think that finishes, right?
So we need to show that, right? So we want AX equal AP.
AX equal AP, yeah, it's actually true.
What did you do after the parallelogram thing?
So because of the parallelogram, we must have that. No, like we have to prove the next step. We must have that AYM should be collinear.
Right.
Because
Yeah, fine. Yes.
yeah, and now C triangle ATM, like we want that AYM are collinear. We know TY is like we want TY to be perpendicular EM and AP is perpendicular to MT, which we know. So can you see something in triangle ATM?
P should
We
be
want
the
MP perpendicular AT.
Yeah, you want
Or
MP.
MP parallel AO, which is parallelogram true.
Yeah. So if you see triangle AMT, AP perpendicular MT and MO, and you see MP is parallel to AO because same, if you add the antipode, these two lengths are equal, and so by whatever midpoints thingy, MP will be parallel to AO, but AO is perpendicular to AT. Therefore, this would imply MP is perpendicular to AT. And from these two relations, you get that P is orthocenter of triangle ATM. So if you redefine Y as let's redefine Y as AM cap PT, then you have that AM, this is perpendicular, AM perpendicular PT. And now you want to prove that Y is the midpoint of PX. In other words, reflection of reflection of P over Y is X.
Isn't AH and A isogonal? So you have that.
Yeah.
Well, never mind.
So now we want to prove PX has midpoint Y. If you see triangle AMT, P is the orthocenter and Y is the foot of T altitude. And you want to prove that reflection of.
Oh, so you basically need to prove AMXT cyclic.
XT is cyclic.
Yeah.
But that circle with diameter OT.
Yeah, exactly.
Yeah.
Okay, so I'll repeat once. We redefine Y, we define Y to be AM cap PT. And if you see triangle AMT, we already have AP perpendicular MT, and then MP is parallel AO, and as AO is perpendicular AT, we have that MP is perpendicular AT. So these two perpendicular conditions gives that P is the orthocenter of AMT, which implies that AM is perpendicular to PT. So Y is the foot of T altitude in this triangle, and they have asked to prove that it lies on the 9-point circle. So we want to prove that we indeed have that PYM is 90, and this must be actually the midpoint of, like, this would imply that Y lies on the 9-point circle, because it's 9-point circle is circle with diameter PM. So we want to prove that Y, which we defined, is actually the midpoint of PX. But if you see triangle AMT, P is the orthocenter, Y is the foot, and ATXOM, this is cyclic because it's circle with diameter OT. Every angle is 90. So X is the altitude cap the circumcircle. So Y is indeed the midpoint of PX. Is the proof clear to everyone?
Yeah.
Cool. I'm not sure about the source, but I was told this is from China 2017. I suggest to draw this diagram from your side too, if you can, but I might just mess up with this diagram here. This is F, center of IG cap AC. IG cap AC is K, and you want to prove AIK is concyclic. Okay, so as Atul said, we want AIKE to be concyclic, that is angle IKA to be equal to angle IEA, but IEA is angle DEA by 2, sorry, DEA by 2 because I is the incenter, and DEA by 2 is DPA by 2, DPA by 2. So you want to show that IKA, this angle is half of angle DPA. So this motivates us to construct the angle bisector of DPA. And now we want to show that this line L, angle bisector of DPA, is parallel to IJ. Then we can remove K from the figure now. Yeah, that we can also try introducing other angular bisector and try proving this is perpendicular.
We have AIJB cyclic because AIB and AJB are both 90 plus D by 2.
AIGB, yeah. Wait. AIGB?
Okay, sorry, never mind.
Yeah. It's, I think so.
Oh, it AIB.
AJB.
AIJB.
It's not.
Yeah, it's not cyclic. No.
It's not okay.
Yeah, like I is in the center of AD. This angle does not look complicated.
Right.
Right. So if we want IJ parallel L. I'll probably give some idea in some 2 minutes. EI pass through cap AD. So you're saying EI cap L should be AD.
Yeah, like EI, AD, and L.
Yeah. Okay, it's actually not, but yeah, exactly. So that's the next step. We have this line L, we have no point other than P on it. So if we introduce this line L, cap this circle APD. So let us call this point, okay, say X. X is L cap this circle APD. Then as PX is the angle bisector of DPA, X is the arc midpoint of DA. And if we see triangle DAE, I is the incenter of DAE. So EI will pass through the arc midpoint of DA, which is X. So XI ER collinear. XI ER collinear. And similarly on the other side, okay, I'll just shift J a bit. Maybe even I. Yeah, so and now you want IJ parallel XY.
Also, PE equals PF.
Yeah.
Because DEA equals CFP and PD equals PFC.
Yeah. PE equals PF. That's one. P equals PF.
Can you tell again how?
Angle DEF will be 180 minus DEA, which is PDA. Angle PEF is angle PDA from this cyclic quadrilateral. Do you see why?
Yeah, fine.
Yeah, and similarly for the other side, you get these two angles. Next step, I'm not sure how to motivate. Like there might be multiple solutions, but in the proof that I know, I am not sure how to motivate the next step. But yeah, probably think about some weird conditions that you can use to prove that Iy is parallel to xy, ij parallel xy, sorry. Angles between ij and xy don't look that computable. So what else can we think about?
Lengths, but there's like no other nice point for the lengths.
Yeah, think about lengths distances. EFIJ. Sure. Yeah, the idea is think about lengths. Basically, try converting this ij parallel xy into some length condition. Okay, so
Okay. Wait.
yeah,
Oh, I thought you can compute angle IFJ in moment.
IFJ.
Yeah, it doesn't look so. No man.
Yeah. Yeah, but
Like
okay.
I got that angle IEF equals to angle JFE.
GFE, okay. Oh,
But I thought it doesn't look helpful. No man.
But there might be solutions using some other concentric quadrilaterals too. Okay, but you have L, and I'm not sure how to motivate this, but okay, I and J are 2 points. How to prove that? Think about some weird condition that would prove that IJ is parallel to L using some length. Try converting this to a length condition.
They have equal distance from the line.
Yeah.
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 So you want to prove distance
Oh.
I.
It's never useful.
That just seems terrible. Like, why would you want to use that?
No, like
Exactly.
it works out. That's the whole point. Is distance J from XY, which is PY. So you want to prove these distances are equal. Whatever.
Okay, so like xi is xa by fact 5,
Yeah.
and you know that angle px is PAE, which is angle CAB.
Yeah.
So you want to show like xi cos CAB is YB cos DBA. Maybe you should
Yeah.
write that down.
Yeah, I'll write down. Yeah. So you want if you see this triangle, you want this distance is Ix into sine of angle PXE, PXI, which is PXE, and this is angle PX. Okay, I'll just call this angle X for now, and this angle as Y. You want Ix sine X Ix sin x is Iy sin y. But angle PXE is this angle. So this angle is x and this angle is y. So you want, but from here you want sin x by sin y is Iy by Ix. Yeah, and now try finishing from here.
And like sin x by sin y is PB by PA, right?
Yeah, but this is what we want. Sin x by sin y is PB by PA. PB by PA. So you want PB by PA to be equal to J, what am I doing? Jy by Ix. So if we want PB by PA to be equal to Jy by Ix.
But like JY is just YB and IX is IA. Sorry, XL.
Exactly. So if you see this circle and the fact phi, from fact phi you get that Ix will be equal to XA. Ix will be equal to XA and Y, oops, what am I doing? Ix will be equal to XA and Yj will be equal to YB. So we want PB by PA to be this by this, YB by whatever.
But this is true since angle XPA is angle YPB by definition.
Yeah.
And angle PXA is angle PDA, which is angle PCB, which is angle PYB.
Yeah.
So sine rule.
Yeah, you can
Or
also
like
finish.
similarity.
Yeah, XDA is
Similarity.
similar to YCP. Yeah, I mean like something. Yeah, okay. PB by PA, you can write PB by PA as what? PB by PA is BC by AD, if I'm not wrong. Yeah, BC by AD. And from here it's just similarity or sine to inverter, as Krutak said. Okay, I'll go over this once again. Firstly, we converted this AIK consequently condition to the fact that we want IJ to be parallel to the angle bisector of XY by angle chasing. So we add the angle bisector of, sorry, what I'm saying, IJ to be parallel to the angular bisector of DPA. So we add the angular bisector of DPA and let it intersect the two circles at X and Y. Then notice that X is the arc midpoint of DA and Y is the arc midpoint of BC. So we have by fact phi XIE and FJB, FJY collinear. And we now want IJ is parallel to XY and which is same as proving distance from I to XY is same as distance from J to XY. And then if you chase lengths and angles, here is just some trig bash and length bash, you reduce to this condition, and which can be seen true by angle chasing. So is the proof clear to everyone?
Yeah.
Cool. So let's move on. Just a second. This is from STEMS 2023. ABC. E F perpendiculars from P and Q will be orthocenter. EFD E oh, drawing circles is hard. This is G and EFD, AED. H. H cap FG. Finally, the 9-point circle cap DA is D. Yeah, T is 9-point circle cap. This I'm not drawing it for now. Yeah, as you can see, the figure is terrible. Okay, firstly, can you make any observations about G and H? So yeah, try claiming something about G and H because they're pretty weird.
Is GH collinear true?
Yeah. Okay. G, AH look collinear. They are actually collinear. Try. Yeah, try to.
Wait, I think you drew DF cap AED's H. Isn't it supposed to be DQ cap AED?
Wait. Sad. Okay. So from intersects DP and here it's DQ. Sorry. DF, DQ, fine. Sorry. This is F. Yeah, try doing GH or collinear.
I think I got it.
Yeah,
So
go on.
Okay, maybe not, but this seems useful. Angle GAF is 180 minus angle GDF, which is 180 minus angle PDF. And angle HAD, sorry,
HAE.
yeah, HAE
Yeah.
should also be equal to 180 minus Q. Wait, what is it?
This is 180 SP, PDF,
QDE, I guess.
QDE. Yeah. G.
And if we want this to be what we say collinear,
Yeah,
we want the sum of this to be 180 plus A.
yeah,
And this should be computable.
yeah.
Because yeah, DF is parallel to AC. So angle PDF is angle DPC, which
is
is angle PCD.
yeah,
Yeah, which is angle C. So
yeah. G, you get GAF is angle C. Like PDF is computable. You can also think as this is 9-point circle. So PDF will be PEF and EF parallel BC. So PEC is ACB. So this turns out to be C. This turns out to be B.
no, I think it's 180 minus C.
Wait, did I just
Like
miss some?
PDF is C, right? So 180 minus.
Oh. Sorry. 180 minus C. This is 180 minus B. And yeah, so angle GAF plus angle HAE is 180 plus angle A, which is BAC. So this implies that GAH are collinear. Can everyone see why? And now you can chase some angles, but you these three are collinear. These three collinear. Okay, can you find angle XFD?
Yeah, it's GFD, which is GAD, which is well, are we supposed to know what that is?
You
Wait.
just
So we get XFDE cyclic, right? Because
exactly.
yeah, XFD is GAD and XAD is HAD.
Yeah. So from these two angles add up to 180 degrees. So XFD plus XCD is 180, and this implies XDEF is cyclic.
Yeah, I think T should also land at circle. That would be
Which circle?
XDEF.
Yeah.
That would be convenient. Wait, what was TAD?
But haven't we given it?
Oh, the AD cap DEF. Yes, yes,
Yeah.
you're right.
So,
So we want to show that XT is parallel to EF. Sorry, PQ.
XT parallel PQ. Wait, how?
Because D is midpoint of arc XT and it's
Oh,
also
right,
midpoint
right.
of
Yeah,
arc
yeah,
PQ.
yeah, yeah.
Proving XT parallel to PQ is enough.
XT parallel. Okay, so this is cyclic.
Yeah. So okay, this is useful probably, but XTD,
XTD.
yeah, the same angle which is varied is equal to angle XCD, which is equal to angle HED, which is equal to angle HAD.
Wait, just a second. HED, which is
HAD.
yeah.
Yeah, so if we want like XT to be parallel to PQ,
Yeah.
the angle between lines AD and PQ should also be HAD.
AD and PQ. Okay.
And like since PQ is anti-parallel to BC, that
Yeah.
angle would be same as angle between BC and the sim median.
Okay.
But yeah, that seems
The okay, Simidian seems a bit.
yeah weird in this
Yeah.
config.
Yeah.
But that does mean that it's somewhat of a nice angle because
Yeah. So like that's one approach. This is one approach, and probably another second approach is dx is dt. Like the basic approach is proving angle dxt is equal to
we can
dtx.
do that.
Yeah, I mean we have so many points on the circle.
But like oh okay, I see. But then okay, I guess we can do this. I haven't calculated it again, but like angle dtx is angle d yeah that thing we angle chase we did, it's like angle HAD.
Yeah.
Okay, but actually not sure. But anyway, so angle dxt is angle
dx
dqt,
is dxt is dqt.
which is 180 minus qdt minus qtd.
qdt minus qtd.
Yeah, and then angle qdt is like HDA.
Okay, 180 minus hda.
angle QD, sorry, yeah, angle QTD is like, what is it? Angle A itself. I think because angle QTD is angle QFD, which is angle QAC.
It's angle A.
Yeah. So, but then HDA minus angle A.
Where's that?
Wait,
HDA.
we mess up some 180 minus.
We might have. Yeah, this, okay, D, I check once. D, XT is DQT, which is 180 minus whatever. QDT is HDA. Yeah, it's correct. It's correct.
Mhm. So we want to show that 180 minus HDA minus A is angle HAD.
HAD?
Yeah, because we found DTX from there, right? From the first thing you wrote.
Oh, right. Yeah. Yeah, so
So, yeah, HAD plus HD is 180 minus AHD,
yeah,
which is AHD is what? Yeah, 180 minus AED, which is okay. We should probably write this too.
yeah, just a second. Yeah. Oh. Yeah, sorry, go on.
Yeah, so 180 minus angle HDA. So what we want is that 180 minus HDA
Minus A to be equal to HAD.
yeah, and like HAD plus HDA is 180 minus AHD.
Yeah. So it
So
is
you want AHD is A?
yeah, exactly.
That's
HD is A, yeah.
oh yeah, that's just true. Yeah. Because angle AHD is angle CED
Is CED.
by consecutivity, and
Oh,
AED
right,
is
yeah.
CAB.
Yeah.
Yeah. So
This
yeah.
is A. Yeah.
Did you have some other approach?
Yeah, no, from here, like till here it was same. From here, I mean, it's just probably something similar only.
I see.
I just computed, I think I computed 180 minus these angles and proved they are equal, but I mean, it's same only. So I think I'll go over this once. So we first proved GAH are collinear by angle chasing. Here we computed GAB and HAC, and from there we get GAH are collinear, and then we got that X lies in the 9-point circle of ABC, that is DEF, by angle chasing, and then we wanted this condition, which was again angle chase. So this was mostly angle chasing. So shall we move on?
Yeah.
Okay. Just a second. Second, yeah. Okay, this will be the last problem. So okay, we have less time. O is the center of CPQ. Prove that DO is perpendicular to AD.
Basically, like we can, the question is saying that let L be the line perpendicular to AD at D.
Mhm.
Let L be the line perpendicular to AD at D. Let O be a point on L, random
Okay.
point. Consider the circle O, or consider the circle with center O radius OC, and intersect it with the line CD and circle ABD. Then you have to show PAQ are collinear.
Yeah. Yeah. You can state it that way too. Should I draw figure that in that reference?
Like it's the same thing only, right? Mostly.
Yeah, it's mostly same thing.
Okay, angle PAB is equals to angle PQC.
PAB is PQC, yeah.
And PQC is POC half.
Yeah.
Okay, what else can we do?
Probably try defining some new point because
ABD cap DC.
okay, if we introduce this point, let's call it D dash, we would have AD equal to DB dash by
Yeah.
isosceles. Yeah, but O is again like D dash. O is not related to D. That's the point. So probably let's try defining something that is related to CPQ because O is related to CPQ. So what other intersection can be defined that somewhat related to C?
Maybe BC cap circumcircle.
Okay, so if we introduce BC cap this circle, let's call it B dash. Yeah, now the next step is probably the crucial step.
Well, you have that since BC is parallel to AD, you have that BB dash AD is isosceles trapezoid.
P, sorry, can you repeat? PB dash. Wait, can you repeat this?
Oh, sorry, I was muted. Since you have BC parallel to AD,
Yeah.
we have that BB dash AD is isosceles trapezoid.
Yeah, B dash AD is isosceles trapezoid. And now in this condition, AD perpendicular DO is same as proving DO perpendicular BB dash.
Yeah.
B dash C, whatever. Okay, we see a circle and some parallel lines. Okay, how do I motivate this? So circle and parallel segments, parallel chords, I mean. Are you people reminded of reams?
Yeah.
Yeah, so by reams you actually get,
Oh, you get QP B dash C cyclic.
yeah, PQ B dash C cyclic. I'll state the angle just quickly. Angle P B dash C is P B dash B is 180 minus PAB, B which is 180 minus PQC. So we must have PQ B dash C concyclic, and we know the center of this circle, which is O.
Right. So you have that perpendicular bisector of QC is. Oh, wait.
Yeah,
oh, yeah, you
correct.
have perpendicular bisector of CB dashes.
Yeah. So we want, this is what we want. So we want that DO is perpendicular bisector, like O is already there. So we want that D lies on perpendicular bisector of B dash C, that is dB dash is DC.
Yes.
We want to do this.
Right. So we want DCB dash to be DB dash C. But DCB dash is DAB. Sorry, yeah, DAB because cyclic.
Yeah.
And DB dash, sorry, DCB dash is also DAB by parallelogram.
Yeah.
So, yeah, it's true.
Yeah, so I'll repeat the proof once. We defined B dash to be BC cap this circle. And by dreams or okay, angle chasing, whatever, we get PQ B dash C cyclic. And then if we convert this required statement, we want that DO is perpendicular B dash C, but O is the center of PQ B dash C, so OB dash is OC. So this should actually be the perpendicular bisector. So we want D lies on the perpendicular bisector of B dash C, but which is true by angle chasing. So is this clear? Okay, so I guess we'll stop. If you have any questions, feel free to ask.
I'll stop recording though.
Okay.